Ball right, ball right. So, for this particular section, we're going to talk about estimation and orders of magnitude. As it says, for this, I've used one of the things in this class which we will use that has the biggest numbers. Okay, so humongous numbers, which is why we're going to work with orders of magnitude, which orders of magnitude is just describing how big or how small a number is. Okay, so you can see from this is a tiny number times 10 to the negative 11. And these are both very large numbers, times 10 to the 30 and times 10 to the 24. And this is a very large number, times 10 to the 11. All right, so in the end, basically, it's going to be useful if we can estimate the size of this number as well as the actual number itself. Okay? So first off, we're going to do orders of magnitude, how big stuff is. So let's look at our first term. It's 6.67 times 10 to the negative 11. So that means we've got a 10 to the negative 11 term. Okay? Next, we have 10 to the 30, 2 times 10 to the 30. So what we do is we multiply it by 2 times 10 to the 30. We're going to basically, for these order of magnitude calculations, omit any actual digits, okay, for now. And then this next one is 10 to the 24, right there, it's 6 times 10 to the 24. Just so you know what these numbers are. Gravitational constant, this is the mass of the sun, mass of the earth, distance between the sun and the earth, all right? So, now we have the top taken care of. Let's look at the bottom. We've got 10 to the 11 squared. If you remember how squares work with those exponents, all you have to do is multiply this out here by what's on the inside. So that means we have something times 10 to the 22, at the very least, inside there. Now, from there, we can estimate what the size of this number will be based on these numbers. All right, if you recall back in the day, if you have numbers that are next to each other, you either add or subtract depending on what they are. So we've got 30 and 11, negative 11, so that means that we should have, of course, 19. All right, so that should be 10 to the 19. Let's go ahead and do this step by step, okay? 10 to the 19, okay? There's those two added together. 10 to the 24 here. And then 10 to the 22 on the bottom still. Okay, 19 and 22, of course, is going to be to the 41. So 10 to the 41. Wait, what? 41? That's not right. Is it? That's not right. 40, like 3, right? 19 and... See, that's the thing. It's important to know what your calculator doesn't, okay? It doesn't know how to do stuff. I didn't want to add those in my head because I'm scared all the time. Okay, and then on the bottom we have 10 to the 22. Now, when you have something on top of another, you cancel out the various zeros, right? So there are 43 zeros there, 22 zeros there. Another way to do that is just to subtract those two numbers. So when we finish up our problem, we should have something times 10 to the 21 or thereabouts, okay? This should be right around what our answer should be, okay? Now, if we take these numbers and we put them into our calculator. Okay, first off, I'll bring my little calculator over here. Okay, so we got 6.67 times 10 to the negative 11. A lot of times you'll see just exponential or e for that. Times 2 times 10 to the 30. Times 6 times 10 to the 24. Okay, so that's going to be the top. I'm going to write the top down just in case I mess it up later on. Let's do 8.0 times 10 to the 44. All over what's going to be on the bottom. So let's do the bottom. 1.5 times 10 to the 11. We take that number and we square it. We get 2.25 times 10 to the 22. Okay, so already we can kind of see how close we are. Okay, on top, we have 10 to the 44. We estimated it to be 10 to the 43. Now, why are they different? Well, take a look at the numbers. We've got a 6 times a 2 times a 6. Remember, that's how the coefficients work. So 6 times 6 is 36. Times 2, it's about 70-something. And it looks like it's about 80-something, right? So that adds an extra digit, okay? So from 43, we go up to 44. Now, the bottom, we estimated it to be 10 to the 22. Was it 10 to the 22? Heck yes, it was. Very good. Now, to finish off the problem, all we got to do is take those two numbers and divide them by one another. So we got times 10 to the 44 divided by 2.25 times 10 to the 22. All right, we end up with a number that is a force of gravity equal to thereabouts 3.6-ish times 10 to the 22 newtons. I've omitted units in between for the sake of the argument we're making. Okay, so we had 3.6 times 10 to the 22. We estimated times 10 to the 21st. That's not too far off. That's a factor of 10 off. That's not bad at all. Okay, now what the whole point of this was is to show you how close you can get by just doing the orders of magnitude, just using the times 10 to those. Okay, if you're to be a little bit more safe, you would estimate out like I did earlier, that's about 6, 36 times 2 is 72, right? So you know it should be about 72 times 10 to the 44 there. It turns out that if you work all the rest of the crap out, it's at 80 right there, or 8 times 10 to the 44. Okay, so this would tell you that if you got something along the lines of, let's say you got 3.6 times 10 to the, let's see, what would it be like, 44, okay? You could immediately say, well, that's not quite inside the realm of what I found. That is nearly squared of what I found over here. That's insane. That's too big. So you know that that answer is incorrect. You could say maybe I got 3.6 times 10 to the third or something silly like that. And you say, well, that's way too small. My number should be in the range of 10 to the 21st. So you can immediately throw out that number. Basically, this is the way you can check stuff. All right. You can check to see how your numbers are working compared to what you think they should be. All right. So it's not too bad. You get used to it pretty quick.